let's start our lectures on section 8.2, trigonometric functions. So this is going to build on the six trigonometric ratios that we learned in 8.1. And, we're just going to naturally expand that to the idea of a function, which I hinted at lots of times in 8.1. In 8.3 is where we start doing calculus. So once we learn these six trigonometric functions and a little bit more about them, then we're going to take derivatives. We're going to do integrals in 8.4. Turns out these sections in chapter 8, they're pretty short, and actually even 8.1 and 8.2 I don't cover nearly as much as what the book offers. Or like if you were to take the Trig class, the whole class devoted to Trig, we're not going to go nearly as much into that because we don't need it. When we get to 8.3 and we start doing derivatives and integrals, all those details, they just, they're definitely useful to have in lots and lots of ways, but the way that we're going to use Trig, doing calculus and things, turns out our calculators can do a lot of the work, and we don't need to look at all the details of doing things by hand, although there's definitely a lot of use to that. It's just not applicable to us. So here I just kind of wanted to say hi. I am now filming these from my house. It's in the afternoon, so the sun's kind of coming down on me here. I'm on my front porch. So behind me, well, you can kind of see, I'll show you my desk here. So yeah, there's our front porch. I've got my setup here with my son's stroller. Got some papers, and as you can see, this is where we keep our freezer for under quarantine. We got lots of good stuff. Yeah, so thought I'd show you guys that. Okay, and also I find these videos come out a lot better filming from here. For some reason, it's a lot sharper on the camera. I think from the videos that I filmed earlier for you guys. Okay, anyway, we're here in 8.2. Let's recap the trig ratios. So you think of a right triangle, sides A, B, the legs A and B, the hypotenuse C, and angle there theta. We'd say that the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. Tangent is opposite over adjacent. And then we've got all of their reciprocals. Cosecant is the reciprocal of sine, C over A. Secant, the reciprocal of cosine. And cotangent, the reciprocal of tangent. I did not mention this before, I don't believe, but we're gonna go further. Every angle that we looked at here for any triangle in 8.1, it was always between 0 degrees and 90 degrees. And so, we kind of generally think of something between 0 and 90. Or if you're thinking of radians, that would be from 0 radians to pi over 2 radians. We're going to take it a step further when we start thinking of these as functions, because we want their domain to be much larger than just 0 to 90 degrees or 0 to pi over 2 radians. One other thing that I did not mention that'd be good to point out now also, speaking of, like how these trig ratios are connected, the reciprocals there also, you may or may not have realized that the tangent of theta is the sine of theta divided by the cosine of theta. And that's pretty clear once you look. Oh yeah, sine is A over C, cosine is B over C. So A over C over B over C. If we take that and simplify it, we would get A over B, the opposite over the adjacent. So another way to think of tangent of theta is the sine of theta over the cosine of theta. Might come in handy. It will in one thing that we discussed today. Okay, so the big point is we're going to go past 90 degrees or pi over 2 radians. So let's jump in with this example, let's find some values for theta equals 135 degrees. I'm going to find the sine of 135 degrees, the cosine of 135 degrees, and the tangent of 135 degrees for you here in the next couple minutes. So let me actually I want to cover up, I'm going to get a folded piece of paper. I'm going to kind of put this here. So if you graph 135 degrees, looks a little something like this. And you think, oh yeah, I mean, you could draw a right triangle. You know, maybe if we pick somewhere on that curve, right? So here we've gone past 90, a little bit beyond. I can still draw a right triangle, just now it's in the second quadrant instead of back here in the first quadrant. And I can label A, B, and C in a very similar way. Now, one big change here, the value of B now is negative. Since we've gone beyond, if I count this direction, I'm on the negative x-axis, so B is now a negative number, A is still positive, and we think of C as being positive, but now B is, okay. Maybe that makes sense. So let's start. What is the sine of 135 degrees? And I'll invite you, just grab your calculator. Make sure you're in degree mode. I'm in radian mode, so I'm going to hit mode, switch over to degrees. And your sine button, mine is right here. Sorry, it's really blurry. 135. My calculator is a little bit more modern, so it tells me the exact value. And that's helpful. But for a lot of these, I just want the rounded version. So in a TI, there should be this like double arrow, and again, that's really, really blurry, but there's this kind of double arrow button there. If I hit that, then it gives me the decimal. So there I have it, the sine of 135 degrees. If I round it maybe to 4 places is what your homework's going to do, 0.7071. Or to be exact, if you are like to be exact, it's the square root of 2 over 2. And we won't go into the explanation of how you could get square root 2 over 2 if you did this without a calculator and the meanings there, because oh man, that's a much longer conversation, and it's a good conversation. It's really helpful, but for where we're going with what we're going to study with these functions and derivatives here, that's not going to be critical that we know the exact value. We got the rounded value. Okay, how about the cosine? Well, you can grab your calculator, punch in cosine of 135 degrees, and it turns out it's exactly the negative of the sine. And, you know, I guess it's another conversation why it's the same value, but why is it negative? Well, hey, cosine is all about the b, right? B over c. And I said a moment ago that b would be negative here. So I've got a negative number divided by a positive number. Cosine turns out to be negative. Finally, I just wanted to finish with tangent. So grab your calculator again, type in the tangent of 135 degrees. And that actually comes out as exactly negative 1. Which makes sense, because a moment ago I told you the tangent of any degree would be the sine of that degree divided by the cosine of that degree. So divide this by this, you know, they're both 135 degrees, so boom, we got negative 1. Or you can just use your calculator for that, of course. Okay, very nice. Let's move to another example. I'm going to go with a radian value this time. In fact, I'm going to go with a negative radian value. Shake things up a little bit. So it turns out a negative angle means we rotate the opposite direction. If it's positive, we're always rotating. Positive is this direction, counterclockwise. Oh, sorry. This way is a negative rotation, and it's just the way it's defined. When they came up with the XY plane, back a couple hundred years ago, right? They said this was quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And they wanted to rotate counterclockwise. So we just got to be consistent with that. So going this way is positive, coming back the other way, we can still do it. We just think of it as a negative rotation. Okay, so if I was to draw that, I'm going to cover this up for now. Try and mimic if we were live in class. So I'm going to rotate down pi over 3. And you may remember that pi over 3 is the same as 60 degrees. So it'd be 90 if I made it all the way here. So, well, looks like my drawing is not quite accurate. Let me fix that. 60 degrees would probably be more like this. There we go. That's better. Okay, well let's check it out. Let's take the sine of negative pi over 3. Again, grab a calculator. Of course, this time be sure you're in radian mode. You might, hopefully you've got a pi button in your calculator. You can just type that pi right on in there. Hey, I got negative square root 3 over 2, but I can switch that with my double arrow. Or maybe your calculator just gives you this number anyway, negative 0.8660. That'll be plenty good enough for us. Let's take the cosine. Turns out that's positive 0.5. Hey, that makes sense. Cosine is positive because we're going, we're going this way, right? On our, if we were to draw the triangle, and I kind of don't really have enough room to do that, but if we were to draw that triangle, there's A, there's B, there's C. Right now B is positive, A is negative, and we always think of C as being positive, so we got a positive cosine, but we got a negative sine. Okay, that makes sense. Finally, tangent. Well, the rounded version, negative 1.7321, or you could just think of it as negative square root 3 if you want it to be exact. Okay, I've got one more for us. How about theta equals 3 pi. Okay, so back to positive, still radians. How would we draw that? Well, 3 pi, if you recall, it takes 2 pi radians to go all the way full circle. Or maybe you just think it takes pi to go halfway. So here's pi. There's 2 pi to go all the way around. 3 pi would be another rotation of 180 degrees, and we end up landing right there. So you can go beyond 360 degrees or beyond 2 pi. You just keep spinning around the circle. And so, hey, let's look at the sine. Oh, and looks like I got cosecant at the same time. Let's do it all. Why not? I did all 6 for this one just to give us a little bit more. The sine of 3 pi turns out it's 0. Okay. What would that mean for the cosecant of 3 pi? Well, isn't the cosecant of 3 pi 1 over the sine of 3 pi? The reciprocal. And if that's 0, well, that's going to be undefined.
I need to get meat out of the freezer. Is that okay?
Let's look at the cosine of 3 pi. Again, I invite you to just grab your calculator.
Sorry.
That'll turn out to be a nice -1. Cosecant 3 pi, it's the reciprocal. Well, that's -1 also. And finally, the tangent of 3 pi. Well, you can use a calculator or think it's that number divided by that number. And again, if we tried to take the reciprocal for cotangent, your calculator will agree that that's undefined as well. Okay, most of your homework is actually just this sort of thing, these last few examples. You're going to be asked to take the sine or the cosine or the tangent or the cosecant or the secant or the cotangent of a bunch of different angles, some degrees, some radians, some negative, some positive, of all kinds of different stuff. And you're gonna use your calculator for all of them. You're gonna round them, and they're gonna feel just like these examples. We're gonna go a bit further in the next video. See you then.